All right, so we're on 1.3 notes, and this is objective number 3. So the first two objectives, the first objective was just finding x and y on the graph. The second objective, what we talked about on example 2, was where is it increasing and decreasing and level, constant, and we learned how to write interval notation, which we'll practice again today. Okay. Now we're going to compare the function to 0, and the big idea, you ready? The big idea, is the function above the x-axis? Is it below the x-axis? Or is it on the x-axis? That's it. Greater than 0, less than 0, 0. You ready? Here we go. Which variable, x or y, does the function notation f of x represent? What does this whole thing mean? It's a y value. Yes, good job. So if f of x equals 0 for a given point on the graph, where is that point located? So f of x equals 0 means y equals 0. So the point is located on the x-axis. On the x-axis. Okay, there could be one point, there could be lots of points. Yeah, okay. But what if f of x is greater than 0? Then where is that point located? So that means where are the y's greater than 0? So greater than 0 means positive, right? So where are all the positive y's located? Very good. Key word, above the x-axis. Should have a sign or on the word wall about these two facts right here. If f of x is greater than 0, then we're above the x-axis. And if f of x is less than 0, what does that mean? We're below the x-axis. All right. Use a marker, highlighter, or colored pencil and trace the graph from left to right for any values or intervals where the graph of f of x equals 0, is greater than 0, or is less than 0. So, you ready? Okay, what does this mean? Y equals 0. What does that mean? On the x-axis. How many places is this graph on the x-axis? I guess we could use a little highlighter here. So right here, 1, 2, 3. And then we need to are those intervals? Is that a bunch of numbers, or are they single points, single numbers? Yeah, like isolated points. So we're going to write a complete sentence because we're almost grown-ups. F of x equals 0 when x equals, let's list them. So x equals -3, 0, and 6. All right, let's go to the next one. Where is the function? Now, what does this mean? If f of x is greater than 0, this means above. So this is not going to be single points now. This is going to be many points. So to write many points, we're going to write intervals. Okay, I'm going to highlight here. Where is the graph? So here is below, below, below. At -3, it equals 0. So at -3, it switches from negative to positive, going through 0. That makes sense, right? Don't points have to go through 0 to go from negative to positive? So we're going up here. This is above, above. There's going to be a little trick right here, okay? A little trick. So you probably want to say f of x is greater than 0 for all the values between -3 and 6. But that wouldn't be entirely correct because do you see how this says greater than? Does it say equal to? No, but didn't we say the graph is equal to 0 at x equals 0? So do you see at 0, 0, is this graph above the x-axis at that point? No, so we can't include that point. You ready? we're going to say from -3 to 0, but then we need to jump over 0 and go from 0 to 6. You ready? We're going to do both ways. So -3 is less than x is less than 0, and then we go from 0 is less than x is less than 6. All right, that's one way. I want to show you another way, because that looks super long and messy, right? We could say all the x's between -3 and 6 except x not equal to 0. That's another way. All right, do you remember the shortcut? The interval notation? So this is called inequality. Say inequality. Inequality. Now we're going to do the interval notation. So when we have a less than without the line underneath it, what do we use? Do you remember what symbol we use? It's going to be the parenthesis. So we're going to say from -3 to 0, make a fat U like that. So that big U, anyone know what that stands for? It means union. What does union mean? To unite. What does that mean? To like bring together. So we're saying this range of values and this range of values are all above the x-axis. Remember how we started this problem? All right, let's do this one now. So f of x is less than 0. What does that mean? Below. So this is below here and below here, and you're describing the x values. So the question is where? Where are they below? And the answer is, let's see here. What's the x value? The first x value we see? -5. Okay, hi, are we going to include -5? Is -5 below the x-axis? Yes. So we're going to include it with a equal sign underneath, sorry. Now, you ready? Is -3 below the x-axis? Why not? It's on the x-axis. So we're not going to include the -3. So we include the -5, but not the -3. Okay, how do we apply that to this piece over here? Are we going to include the 6? No. Are we going to include the 7? Yes. And how would we write that in inequality notation? So with the line underneath it, when it's included, what symbol do we use? The bracket. And then here, no bracket or the parenthesis, it's not included. And we're going to put a U, unioned with the 6 not included and the 7 included. All right, identify the domain of the graphed function. So what is the smallest x value you see and what's the greatest x value you see? So the smallest x value on the graph is -5, and that's included. And the largest x value, it looks like this image got cut off, so let's make sure we use these two images. So it looks like it goes to 7, yes? X equals 7. All right, and what's the smallest y value? So domain is x values, and the range y values. What's the least y we see? -4. Everyone see this? -4, this point here, -4, and then the y's go from -4 to the highest y value graphed is 4. Once you've completed the 3 pages of notes, you are ready to practice. So the practice is on the back, and there's examples of these on the front side. So it mostly matches this side here, the first example. Okay?